Welcome to Electrolysis with Ma'am T. Electrolysis falls under chemical change, and I could not include it on our previous video because that video was too long. Hence, I made a separate video. Guys, I cannot emphasize this more than I've already emphasized it. Definitions are the key. If you really want to understand electrolysis and be able to answer whatever type of question they're gonna throw your way for electrolysis, you need to know your definitions. If you can understand what they mean, what these terms mean, you can answer anything they throw your way. So the first definition that we're going to look at is electrolysis. Electrolysis is a chemical decomposition of a substance when current flows through it. So what do we mean by chemical decomposition? So what I actually mean is this. If I have H2O, I break this back to its elements that made up the H2O. So it goes back to being oxygen and hydrogen. That is the decomposition of a substance. I have a compound. It always be broken down to form the two elements that made up that compound. That is what chemical decomposition means. Then we have an electrolyte. An electrolyte is said to be an ionic solution that dissociates into ions and conduct electricity. Example: NaCl, sodium chloride. So we all know that sodium chloride is a salt, but when we dissolve sodium chloride in water, it becomes an ionic solution, forming the sodium ions and the chlorine ions. Then we have an electrode. An electrode is a part of the electrolytic cell. It is a point in an electric circuit where electrons can enter or exit the circuit. We have two types of electrodes. We have the cathode and we have the anode. Please be careful. A cathode does not mean cation. Anode does not mean an ion. A cathode is what? A cathode is a negative electrode where reduction takes place, and an anode is a positive electrode where oxidation takes place. If you can recall from the previous video, we said that reduction is the gaining of electrons. That is why my cathode, the arrow is pointing from enter. If electrons are going to enter, it means they are going to be gained. Whereas an anode is where oxidation takes place, and we know that oxidation is the loss of electrons, so the electrons must exit, they must leave. Remember what I said, don't confuse cathode and anode. Okay, this is what I meant. A cation is a positively charged ion formed when an atom donates an electron. An anion is a negatively charged ion formed when an atom gains an electron. So you see, a cation and a cathode are not the same. An anion and an anode are not the same. Please be careful with that. Electrolytic cell. So an electrolytic cell is a type of cell that converts electrical energy into chemical energy. And a way for you to identify that the cell that they gave you is an electrolytic cell, you're going to see two electrodes, and there must be a power supply connected to the electrodes. Or what? The electrode must be connected to the power supply. The power supply can be either a battery, or it can be a cell, or any form, as long as it supplies power to the circuit. Let's assume that this is our beaker. So inside our beaker, what do we have? We have what is called an electrolyte. Remember, what is an electrolyte? It is like an ionic solution that dissociate into ions when current passes through it. So remember, our electrolyte is made up of a compound that actually dissolved in water to make an ionic solution. So we're going to have X, Y. Okay, so the Y part, we always consider it to be our non-metal. And because it's our non-metal, it is going to form negative ions when it dissociates in the water. Then our X, we always take it to be our metal. And when our metal dissociates in water, it is going to form cations, the positive ions. Okay. Now, we need to figure out which of our electrode is going to be positive and which one is going to be negative. In order to find out which electrodes are going to be negative or positive, the battery or the cell that these electrodes are connected to will be the ones helping us to identify. So this long line is the positive line, and this short line is the negative line. So positive, negative, right? So now think about it. If this terminal is positive, between your cation and your anion, which one will be attracted to this electrode? Keep in mind the law of attraction or repulsion. So now it means that my Y, my anions, will be attracted to the positive terminal, and my X, the cations, will be attracted to the negative terminal. We good. Therefore, I can now give a name. To this electrode. It is positive, and anions are attracted to it. So it means the name of this electrode is going to be what? It is going to be an anode. Right? So it means this side, it's negative, and the cations are attracted to it. The positive charges are attracted to it. So I can give the name cathode. So you see, if you do not know your definitions, you won't be able to analyze anything or know what is what. Okay. We said that our anions, the negatives, are attracted to this terminal. And we said that electrolysis is the decomposition of a substance into what? Into its element. We're taking back the compound into the elements that made that compound. So it means that my anion Y, something must happen to it so that it goes back to being its element Y. So because it is negative, it simply means it did what? It had gained electrons, so that it must be negative. So if we wanted to go back to its original state, it means that it has to do what? It has to give back the electrons that it had gained. So it means that my half reaction is going to be what? It's going to be Y minus arrow back to its original state plus the number of electrons that it had lost. Plus the number of electrons that it had gained. So now it is doing what? It is giving them back. So because it loses an electron, we say the reaction is what? The reaction is oxidation. And because Y minus underwent oxidation, it means that Y minus is what? Y minus is oxidized. Okay? So the one that undergoes oxidation, the one that is oxidized, it becomes which type of a agent? It means that my Y minus is it's a reducing agent. Right. Remember, a reducing agent is a substance that undergoes oxidation and it causes the other one to do what? To gain electrons. Let's look at this side. The positive charges are being attracted to the negative side, and that is called the electrode. So that means what? Something must happen to these positive charges so that it also can go back to being its element. And in order to do that, it means what? It was positive because it had donated electrons. Now it has to gain back the electrons that it had donated so that it's able to go back to being its element. So I have reaction here. Will be X plus an electron giving me the original element. So it means the type of reaction that is taking place at the cathode is what? It is reduction. And what does reduction tell me? It is the gaining of electrons. Okay, so it means that X plus is reduced. And if X plus is reduced, it means X plus is what? Is a oxidizing agent. So now, remember we said that the electrodes are a point whereby electrons can exit or enter into the circuit. Let's look at it. At the anode, what is happening to the electrons? The electrons are given off, the electrons are lost. At the cathode, what is happening? The electrons are being gained. So that it means electrons are being transferred from the anode to the cathode. Do you see? So our electron transfer, it's always from the positive terminal or from the positive electrode to the negative electrode. Guys, if you've paid attention, I only use definitions in order for me to analyze the circuit. So if you can know your definitions, you'll be able to analyze properly and answer correctly. Whatever type of electrolyte you're going to get, this side of the information and this side of the information does not change. So now, remember, oxidation and reduction are reactions that are happening microscopically. We cannot see them with our naked eye. So, but for us to see that the experiment succeeded, that it actually happened, there's microscopic observations that we can make. And what are those? At the cathode, I am going to see metal deposits or coating. Why? Because the X is what? It's a metal that was attracted to the cathode. And it goes back to being its original element, which is the metal. That is why I'm going to see what? I am going to see metal deposits or coating here. Let's do it. So there's going to be some form of coating there to show me that a metal was formed. And at the anode, I know that my nonmetal is the one that is attracted to my anode. So this nonmetal will always want to go back to its original state. And its original state was a gas. So it means I'm going to see what? I'm going to see formation of bubbles here. So there will be bubbles that are forming there. And these bubbles, when they form, they're actually showing me that a gas is formed. Lastly, what we need to know is the applications of electrolysis. There are about 5. Electroplating, galvanizing, purification of metals, extractions of metals, preparation of chemicals. Remember, I'm not going to go into detail as to how these work. You just need to know them. Let's look at this question paper. This is in November 2023, paper 2. Question 6. They say the experimental setup below was used by technical science learners to investigate the electrolysis of copper chloride solution. Right? It's a solution. So AQ, remember, aqueous solution. I have electrode A, I have electrode B. They told me what is the electrolyte inside there. Number 1, define the term electrolysis. We know that electrolysis is a chemical decomposition of a substance when current flows through it. Why is carbon preferred as an electrode? Okay, so this could be because carbon is a good conductor. It's a good conductor of electricity. What observation will be made at the electrode? Now, I don't know what electrode A is. I don't know what electrode B is. They did not tell me. But now I can go look at it. The long line will be the positive. The short line will be the negative. So it means the positive electrode B is now my anode. And the negative electrode A, it is my cathode, right? So I know that at the cathode, copper, because it's positive, will be attracted this side. So I know this side, Cu2 plus, will be attracted. And I know that this side, the Cl minus, will be attracted. Right? Okay. Now let's answer them. What observation? Remember, observation, what can I physically see with my eyes? So at electrode A, I am going to see copper deposits, or I am going to see coating. Right? You know the color of copper. You could have mentioned that you're going to see brown copper deposit. Okay, brownish red copper deposits or brownish red coating. At B, what are you going to see? You're going to see bubbles. These bubbles are the ones that are telling you that there is a formation of a gas. Write down the half reaction that take place at electrode A and B. So, what happened at A? Cu2 plus was attracted there. And because it wants to go back to being a metal, it must do what? It must gain the 2 electrons that it had lost, so that it does what? It goes back to being copper. Remember the copper 2 plus is an aqueous solution, and then the copper that is going to form, it will be a solid. Then let's look at electrode B. What happened in electrode B? We had chlorine, Cl minus, attracted there. Because it's a minus, it means it has to donate back the electrons that it had gained. So it means, okay. So this is an aqueous solution also. It has to give back what it had gained. So it will form Cl2 because it's a diatomic element. It's a gas plus the electrons that it lost. But because chlorine is a diatomic element, our reaction is not balanced. Those two is telling me that this person is not balanced. So we need to balance this equation. Remember, for diatomic elements always, the equations must be balanced. So it means I have to do what? I have to lose. It means that it has to lose 2 electrons, and then 2 chlorine ions are going to form. Write down the overall balanced net reaction of this cell. Okay, this one technically it's not in your textbooks, but let's just cover it. So to write the overall net reaction, you're just going to write the 2 equations that you have and then combine them. So I'm going to have Cu2 plus Aq plus 2 electrons, giving me Cu, the solid. And I'm going to have 2 Cl minus, the aqueous solution, giving me what? Cl2, the gas, plus 2 electrons. So the number of electrons this side is equal to the number of electrons this side. And because they're in opposite sides of the arrow, the electrons this side are the reactants, and the electrons this side are on the products. They have to cancel out each other. And once they cancel out each other, your net ionic equation now becomes Cu2 plus Aq plus 2 Cl minus Aq, arrow, copper, solid, plus Cl2, gas. Six point six. Write down 2 applications of electrolysis in technology. So you can say electroplating or galvanizing, whatever ones that you decide you want. So this is electrolysis. I'll do other videos for other types of questions that we find that are different to this one.